The Americans landed on the moon before the Russians, and the Russians made the first space station. But everything changed on November the 20th, 1998. President Ronald Reagan directed NASA in the mid-1980s to build an international space station within a decade.
Will permit quantum leaps in our research in science, communications, in metals, and in life-saving medicines which can be manufactured only in space.
First, the United States collaborated with Europe and Japan. Then, in 1993, Russia was invited to join the project because it had the most extensive experience operating orbital space stations. By 1998, all 5 space agencies had signed on to the project. This is Space Journey 101, and today we will look at the International Space Station. But even when working together, how can we establish such a massive structure in space? The International Space Station weighs nearly 400 tons and covers an area almost as long as a football field, and one solar array's wingspan is 112 feet long and 39 feet wide. It would have been impossible to construct the space station on Earth and then launch it into space all at once, because there is no rocket large enough or powerful enough. To avoid this issue, the space station was launched into space in pieces and gradually assembled in orbit 400 kilometers above the Earth's surface. More than 40 missions were required for this assembly. The first module, Zarya, was launched on a Proton rocket on November the 20th, 1998. 2 weeks later, the NASA Unity Node 1 module was launched by Space Shuttle Flight STS-88. During STS-88, astronauts performed spacewalks to connect the 2 parts of the station. Later, other parts of the station were launched on rockets or in the Space Shuttle cargo bay. More than 80% of the hardware planned for the ISS in the late 1990s was orbited and is now part of the ISS's inventory. What is the ISS? The International Space Station was designed as a series of linked cylindrical modules that are solar-powered and cooled by heat-radiating loops. These are divided between the station's 2 major segments: the Russia orbital segment, which is operated by Russia, and the US segment, which includes contributions from a variety of countries. The ISS's US and Russian segments both generate power and house laboratories, living quarters, and docking ports. The segments are linked to a larger structural truss that houses the station's solar arrays and thermal radiators, allowing astronauts to move between them. Canadarm2, a Canadian-built apparatus that functions as a large remote-controlled space crane used for a variety of tasks ranging from moving equipment to capturing inbound spacecraft. Kibo, a Japanese science laboratory space with an external porch that is used for experiments in the vacuum of space, is the single largest module on the US side.
So right now, we're in the Japanese laboratory. It's one laboratory out of many here on the International Space Station. It's actually on the left-hand side. If I was the International Space Station and I was flying through space like this, my left hand would be where the Japanese laboratory is.
The nearby Node 3, or Tranquility module, houses the European-built cupola, which provides astronauts with breathtaking views of Earth.
The space station is one special place for windows, and they're called the cupola, and that's where we fly Canadarm2 from.
In 2016, NASA attached an inflatable habitat to the space station for the first time, possibly paving the way for future inflatable space hotels and tourist destinations. The solar panels and radiators provide power and cooling to the station. The radiators must keep the station cool, while the sun heats one side and the cool vacuum of space freezes the other. NASA and its collaborators created a method for mounting solar arrays on a blanket. The blanket can be delivered to space, folded like an accordion and then deployed or spread out to its full size once in orbit. When the blankets were in orbit, ground controllers sent commands to expand them to their full size. To provide maximum power to the space station, gimbals are used to rotate the arrays so they face the sun. The 4 array sets can generate 84 to 120 kilowatts of electricity, which is enough to power more than 40 homes. By 2020, astronauts on the International Space Station are expected to have conducted approximately 3,000 scientific experiments. Some of the most well-known experiments carried out on the International Space Station include the Alpha Magnetic Spectrometer particle physics experiment discovered antimatter in cosmic rays, antiprotons and positrons.
The alpha magnetic spectrometer, which is collecting energy from the universe, it's collecting dark matter from the universe.
Earth-viewing remote sensing experiments, such as the orbiting Carbon Observatory 3, which measures carbon dioxide levels in the Earth's atmosphere from above. Goodbye, ISS. Unfortunately, due to structural issues related to its age, this magnificent piece of engineering will most likely be decommissioned in 2031. In recent years, for example, there have been several air leaks in the crew's living quarters.
Russian flight controllers and the flight controllers here at Mission Control in Houston have been noticing a stream of particles coming out of the Soyuz MS-22 vehicle that is attached to the Roscosmos module on the Earth-facing side of the Russian segment of the International Space Station. We do not know what the source of this stream of particles is at the point.
NASA anticipates that private companies such as Blue Origin will launch orbital laboratories and/or space platforms before that date. According to NASA's transition strategy, these commercial low Earth orbit stations will eventually replace the ISS. Roscosmos, the Russian space agency involved in the ISS's development, has already stated that it will leave the ISS after 2024 to construct its own station. The ISS is scheduled to be deorbited in early 2031, with any remaining debris directed to land near Point Nemo, the Earth's farthest point from land. In the next episode, we will talk about the Hubble and James Webb telescopes. Stay tuned.